Spacing views is fundamental for building a well-designed user interface. In the previous video, the screen we implemented was not appealing to the eye because we haven't used any white space. In design terminology, the blank or unmarked portions of a page or a screen is called white space. Without proper use of white space, the screen can look terrible. See this example. This was a screen design I found from dribble.com. Full credits to the author. And then I removed all of the white space from the design, and now it looks terrible. You can see them side by side. Let me do a close-up. As you can see, design with proper white space looks way better than design without enough white space. Material guidelines is a great resource to read about how to space views and how much space you should put. But instead of going into details, let's see which attributes we can use to put white space between our views. For all of the views, we have two different types of spacing attribute. The first one is margin, and the second one is padding. Margin sets the outer spacing of the view, whereas padding is used to set inner spacing of the view. You can use layout margin to set spacing to all four edges, but also you can use margin start, top, and then bottom to set spacing for all specific edges individually. It is same for the padding. You can use Android padding to set padding to all four edges, but from inner side. Also, you can use padding start, top, and then bottom to set spacing for each individual edge. This kind of inner-outer spacing system is well known to UI programmers, and similar systems exist for iOS and web development and other platforms as well. View bounds is the boundaries of a view, and when you set a background, it covers the area contained by the bounds. Since margin sets spacing outside of view bounds, it's usually used to put space between views. And since padding is used inside of view bounds, it's used to set spacing between view boundaries and the children or the content. I'm gonna start by adding some padding for linear layout. When I add padding to linear layout, it will apply it to all four edges. And it's good, it's what I want. So padding 16 dps. Okay, it already started to look better. And now I want to add a top margin to this welcome to our cafe text view. Margin top 8 dp. And also I will cheat here and make the text size a bit bigger, maybe even bigger, so that it looks even better. Also, now I will add a margin bottom to this welcome to our cafe text view. I already added a top margin. Now I'm adding a bottom margin, and that can be, let's say, 33 dps. Okay, maybe I can use the same value 32 for the margin top as well. Now maybe I can add a margin bottom to this one, like 4 dps. And lastly, I can add some padding to the button so that the space between view bounds and the content of the button can be bigger. Yes, it grew a bit. Maybe I can use more. Okay, yes. Now with 32 dps, the button became bigger. Or maybe I can stick to 24 dps. Yes. So that's how you add spacing to all of your views. For example, if I go and change this to 32, all of the edges get affected from this change. That's enough for this video. See you in the next one. Linear layout was aligning its views in a linear fashion, horizontal or vertical. Relative layout is more flexible than that. Using relative layout, we can align and position the children views relative to the parent or relative to the other children. Let's see how we can align them relative to the parent. Let's say we have a child view in the relative layout, which is the parent. We can align this child to the top left corner using align parent start true and align parent top true. The other attributes like align parent and bottom, horizontal, vertical, and others, they are set to false by default. These true and false values are called Boolean values, like binary values. It can either be true or it can be false. There is no third option. So it's like a toggle that you activate, or it's like a switch you activate, okay? So when the align parent start is set to true and align parent top is set to true, then the child view is set to top left of the parent. When we change this and use align parent end and align parent top, then you can see that child is positioned to the top right. The same for align parent end true and align parent bottom true, or align parent start true and align parent bottom true. So you can pick two of these four attributes if it's meaningful, meaning that like you cannot use align parent start and end at the same time. But if you pick one from the horizontal direction and one from the vertical direction and combine them, you can position your child accordingly. Or you can use, for example, layout center vertical to true and also align parent start to move the child to this position. You can also use align parent top with center horizontal true to put the child here. You got the point. You can pick two of these values and they should be meaningful ones and combine them, setting them to true and deleting the other ones, or maybe setting them to false. You can position the child view in the parent view. Also, if you set center horizontal true with center vertical to true, it means the child will be centered inside parent. But instead of using two different attributes, you can use one attribute, which is center in parent, and you can set this one to true and the result will be the same. And secondly, we can align the children relative to the other children. Again, let's say we have a child in the parent relative layout, which is, let's say, using this attribute, center in parent, to true. And let's say we add another one, the blue square, which is a second child. And let's say we give them these IDs. IDs are important if you want to align views relative to each other, because with IDs we can refer to these views in XML. So in the red view, in the red child, we are setting the ID to red using this notation. And for the blue view, we are using again the same notation to set its ID to blue. So now that you understand we have two different views and we are adding attributes to both of them, we can do something now. We can add one more attribute, and that is layout to start off red. So using this layout to start off in blue, we say that, okay, I want to align this view to the start of red so that it uses this position here to align blue. If we instead say to end of red, then it aligns it to the end of red. We can also use layout above, and again, instead of using true and false, we are giving ID references here. And now these two attributes are combined together to move blue to the top right corner of red because it aligns it to the end of red. Also, we say that it should be above red. We can also say, let's say, align bottom. If you say align bottom, it moves the blue view here next to the red view. Or you can use below, and which will put blue below the red. So there are lots of different attributes like this, the start of, the end of, above and below, and you can use these attributes to create complex screen layouts using relative layout. I won't cover each and every combination of these attributes because you already have a good understanding of how these attributes work. But one last thing I want to mention here is you need to note the difference between setting a new ID and referring to that ID. When we're first defining the ID, we use a plus between the word ID and symbol @ But when we are referring to it, this is not a typo, when we are referring to any ID, we don't use plus because plus means we create a new ID. But here we are not creating a new ID, we are referring to this one which we created before. This is how relative layout works, and see you in the next video to compare linear layout and relative layout. Let's try to cover the differences between a linear layout and a relative layout so that we can understand which one to use when. Linear layout is a good choice if you want to align views linearly, vertically or horizontally. If you have a more complex screen that you cannot implement with linear layout, you usually use relative layout. So for simple layouts like this, you can easily use linear layout, but for more complex layouts, you can use relative layout. Also, please note that linear layout does not allow views to overlap, but in relative layout, you can overlap views. In linear layout, we use orientation and gravity to position children. But in relative layout, we have a bunch of attributes to control the position of the children. And children can align themselves relative to parent and relative to other children. Linear layout and relative layout both are useful when laying out and positioning views. However, in some cases, one single linear layout or one single relative layout might not be enough for you. So for those cases, we need to nest or combine multiple layouts. So see you in the next video to learn about how to do that. In the previous video, we learned the differences between linear and relative layout. And now let's see how to combine multiple view groups so that we can create sophisticated screens. For example, let's say you have a screen like this, where first three views are vertically aligned and the next three views are horizontally aligned. With the information we know that we can create first three or the last three with a linear layout because it looks like a linear alignment. But how to do both horizontal and vertical? To start, we need to understand which portions we can group. So the bottom three views can be grouped into a horizontal linear layout, and the rest of the views can be represented by a vertical linear layout. This kind of structure is possible because you can nest one linear layout into another. If you write this kind of code where you put a linear layout into another one, you can achieve this kind of result. So to see this better, the first children of the outmost linear layout is this view, and 2 is here, 3 is here. Now the important part, the fourth children of the outmost linear layout is another linear layout. So fourth children is this one, see? And A, B, and C are the children of fourth children. So this means A, B, and C are grandchildren of the outmost linear layout. These are the children and these are the grandchildren, because 4 is also a child of linear layout. Okay, let's see another example. We know that this kind of screen can be easily created by a linear layout, but we have an overlapping view somewhere. So if this view was not here, then it is super easy. It's just one vertical linear layout. But how can we add this overlapping view? First, let's group them again. So the green views can be represented as a linear layout, which is a vertical one. And pink is overlapping this linear layout altogether. If we wrap these into a relative layout, we can easily achieve this kind of result. So the end result will look like this. Relative layout has 2 children. One is the linear layout and the second is this pink square. Let's see the code. So again, the first children of the relative layout is this linear layout, and the second children is a square view. And this A, B, C, and D are actually grandchildren of the outmost relative layout. So with this nesting approach, you can combine the properties of relative layout and linear layout. There are of course a lot of different combinations where we can combine 3, 4 linear layouts or relative layouts with each other, but it doesn't make sense to see it all in slides. So let's do some real coding starting from the next video.